So in this part of the video, I'm going to explain kind of how inverse tangent makes sense. But to do that, we have to clarify what do trig functions actually tell you, because SOHCAHTOA is actually not quite right. It's a little bit misleading. So last year, you were probably told that sine of an angle tells you the length of the side opposite to the angle divided by the length of the hypotenuse. And that's true for angles that are in this kind of first quadrant. If we're thinking about a point on the unit circle whose radius is 1, then that means the length of the hypotenuse is 1. So here, this is just 1. So in that case, sine 30 degrees is really just telling you the length of this side, the opposite side. But I was in the process of saying that that is only true for angles between 0 and 90 degrees. If you have a negative angle, so if you've got an angle between like 0 and negative 90, it doesn't tell you the length of the opposite side, it tells you the y-coordinate. And I guess in this case we can still divide by the hypotenuse, which is 1. So what's the difference? My drawing, as usual, is not to scale, but the sine of 30 degrees is going to be 1/2. And here that describes both the y-coordinate and also this length. But a point down here, if I wanted to describe the length is 1/2, but the y-position, the y-coordinate, is at negative 1/2. So this is important because it gives you a different understanding of what the tangent function is, and we're leading towards inverse tangent. So on the unit circle, the sine of an angle is just telling you the y-coordinate of the point that's at that angle on the circle. And cosine of an angle will tell you the x-coordinate of the point on the unit circle. So tangent is just sine divided by cosine, which means it tells you the y-coordinate divided by the x-coordinate. So what that means is that the tangent of these two different angles is actually going to give you the same value. So tangent of negative 30 degrees here is going to give me the y-coordinate divided by the x-coordinate. So that's negative 1/2 divided by positive root 3 over 2. So that's going to be negative 1 over root 3. And over here, at an angle of 150, tangent of 150, it's going to give you 1/2 divided by negative root 3 over 2, which is also the same value. So what happens if I take the inverse tangent of both sides of this equation? The way that you are thinking about this up till now is that tangent and inverse tangent undo each other. So on the left-hand side, you have negative 30 degrees, and on the right-hand side, you've got inverse tangent of this y-coordinate over x-coordinate. But if you do the same thing here, you get this. And this can't possibly be true, both of these at the same time, because as you can see, inverse tangent takes the same input, but would be giving two different outputs. So that would mean that it wouldn't be a function. But it is a function. So what's going on here? Why can't inverse tangent actually give you these two different angles? It sort of makes sense, because if all I tell you is a number that represents y-coordinate over x-coordinate, in this case it's negative, but if you just know the overall division, you don't know which one of these two was negative. And in this case, it was the y-coordinate that was negative, but in this case, it was the x-coordinate that was negative. So that's the idea. The idea is that the input to inverse tangent is this ratio of the y-coordinate over the x-coordinate. But that single number can describe several different angles on the unit circle. So the solution is that inverse tangent is just going to tell you which angle between negative 90 degrees and positive 90 degrees will give you that particular y divided by x-coordinate. So for this particular example, this is the one that isn't true. If you take inverse tangent of negative 1 over root 3, it's going to give you negative 30 degrees, because that's the angle in that angle interval between negative 90 and positive 90. So the way this connects back to the last video is if you have a point whose coordinates are not in this part of the unit circle, they're in this part of the unit circle, and you use inverse tangent, it's not actually going to give you the angle that points at your point. It's actually going to give you an angle that has the related coordinates, but in this part of the unit circle. So what you have to do is you have to think about the symmetries of the circle and figure out how does the angle that it gives you, this negative 30 degrees, how does that actually fit with the angle that you want? But since that seemed confusing for people, if all you really want to do is figure out an angle, then it's easier to forget the actual pluses and minuses and just treat this as a distance of root 3 over 2, and you don't care what the x-coordinate is, and treat this as a distance of 1/2, and then you can use the inverse tangent to find this angle here without worrying about any of that.